Hi, I'm Wim Blodgett, President of Holland Pump Company. Welcome to our webinar on everything you need to know about Wellpoint Dewatering. I'd like to thank our Director of Marketing, Amy Fletcher, for facilitating this event and for the great graphics presented. Today, I am joined by two key employees. Jamie Hahn, District Sales Manager, started at Holland Pump as a service tech, became a salesman, then a branch manager, and finally a district manager. Jamie has done hundreds of well pointing projects in Southwest Florida. We are also joined by Terry Kilker. For over 40 years, Terry has worked in sales for Sander Power Equipment in the greater Pennsylvania market and is one of the most respected pump men in our industry. Holland Pump was formed in 1978 and has been involved in well pointing for many years. In 2020, we acquired CDPW Inc., also known as Complete Dewatering. Complete was established in 1923 in New York before moving operations to Florida in the 1930s. Complete Dewatering began the manufacturing and development of groundwater control systems to pre-drain and stabilize wet soils. Complete was a market leader in the industry by providing innovative solutions and equipment in even the most difficult site conditions. Complete was the first company to provide an all-plastic snap-together wellpoint system, which most other companies now use. Complete was the first company with 260 CFM dual vacuum pump system on its wellpoint pumps, providing redundancy and greater reliability. Complete Dewatering inspired many of the current competitors by having them as employees before they ventured out on their own to begin their own operations.
Hi, I'm Terry Kilker. Header is typically made from Schedule 40 PVC in 6-inch, 8-inch, and 12-inch diameters in 20-foot sections. Depending on the requirements, grommets are typically located every 2, 3, or 4 feet on center. Header sections are typically joined with header sleeves, which are banded onto the header. When assembling, grommet plugs or caps are inserted to ensure a good vacuum. Holland Pump Company also makes swings, are typically 3 feet in length, are made of 1.5 and 2-inch diameters, and usually come with a cutoff valve, which is to use to tune or isolate well points. We make ditch mops, which are very long swings made to mop up surface area where there is water present and needs to be dewatered.
Hi, I'm Jamie Hahn. Holland Pump has our own machines to make well points for both 1.5 and 2-inch applications. Well point screens are typically 3 foot long, but can be made up to 10 foot in length and can be horizontal or vertical slots that are 10 1,000ths to 15 1,000ths in thickness. 3-foot well screens can be glued to riser pipe to make points from 13 to 24 foot in overall length. Or we can make one-piece well points where the well screen and riser pipe are made of one continuous length of pipe. Holland Pump offers some self-jetting points as well. Holland Pump also supplies all the special fittings such as 22s, 45s, 90s, Ts, reducers, and increasers, material such as PVC pipe and hoses that wellpoint applications require. Holland Pump supplies jetting rod for hand-jetted applications, makes 4 and 6-inch wellpoint punches when hand jetting is not possible. Also have 3 wellpoint drills for rent for more difficult installs.
Holland Pump has engineered prepackaged wellpoint systems to take the guesswork out of ordering and dewatering a construction site. The small systems are often used by contractors who do utility hookups, pipe repairs, or installation of underground tanks. All other systems contain quantities of fittings for foundation layouts, U-shapes, and the line utility work. Holland Pump makes a variety of pumps that are made for well pointing applications. Jet pumps are typically diesel-driven skid or trailered units with hand priming systems. Jet pumps are used to supply water at high pressure for hand jetting or for punches and drills. Our rotary wellpoint pumps feature positive displacement that have a fixed amount of displacement per pump revolution. Every gallon of water equals 0.133 CFM. So when a positive displacement pump is rated for 1,200 gallons per minute, that means it is 160.4 CFM. When you need to go deep, rotary lobe wellpoint pumps are the first choice. Our vacuum assist wellpoint pumps are typically solids handling centrifugal pumps with vacuum priming systems rated up to 260 CFM. Where versatility and air handling is more important than fluid handling, vacuum assist Wellpoint pumps are a great choice.
Many times, a contractor will have a lot of well pointing experience and knowledge of local soil conditions where consultation with a hydrogeologist may not be required. In this case, the basic questions are: how deep is the excavation and the water table? How wide is the excavation at the top? How long is the excavation at the top? How far do you have to carry that discharge away from the excavation site? How close is the source of water for jetting? What's overhead? Wires, trees, overhangs, etc.
In Florida, the normal soil conditions we encounter are fine sand, sand, clay, coquina, shell, swamp, and organic soils.
In the Northeast, the normal soil conditions we encounter are clay, silt, loam, coarse sand, rocky, and granite.
A basic concept in Wellpoint dewatering is what we call the cone of influence. The cone of influence is the drawdown gradient created by the dewatering system. The size of the cone of influence is influenced by the permeability of the ground. The higher the permeability, uniform soils, the flatter the cone of influence. Wider wellpoint spacing is permitted. The lower the permeability, such as stratified soils, the steeper the cone of influence, and the closer wellpoint spacing is required.
Well point length is determined by the work to be executed. For example, if the bottom of the storm sewer pipe is going to be 20 feet down from the surface, then the well points we would use will be 24 feet overall, which allows the well screen to be at least 3 feet below the cut. When a pipeline is being installed and the cut needs to be dewatered, a single line of well point header is installed up to 500 feet in length.
For smaller excavation that involves pipe installation, a horseshoe-shaped well point install is often required. This allows equipment to enter the site from one end to complete the excavation. For large foundation jobs, a perimeter well point system is installed, and that system is often supplemented by secondary pumps to complete dewatering for elevator pits or other features that require special consideration. In the last 20 years, a popular method of dewatering has been sock dewatering, and on these applications, well point pumps are connected to the sock system to dewater.
Pump placement is critical consideration. Make sure it is in a good spot for easy to fuel, easy to maintain, and works well with the discharge plan. Pumps should be at the same elevation for proper suction lift. It's a good practice to locate the pump in the center of the header to reduce friction loss.
Dewatering permits usually specify how much groundwater can be removed per day and how the method of discharge is to take place. Discharge could be in a storm drain, in a creek or stream, or in an injection well. Another consideration is that any discharge water has to have low turbidity. Typically, an advantage of well pointing and sock dewatering is that the water has already been filtered and has low solid content relative to other methods.
At higher elevations or when excavations are deep, multi-stage well point system is recommended. In this method, a perimeter well point system is installed for the first 15 to 20 feet, then a secondary well point system installed, which allows the excavation to be another 20 feet deeper. Examples of applications that might require multi-stage well point system are pump stations and nuclear facilities.
Groundwater modeling. If you aren't 100% sure of local conditions, you will want to rely on test well data and geotechnical reports. Making a mistake can be very costly. For example, the well screen slot thickness may be better at 10 1,000ths than 15 1,000ths of an inch. The soil may not be appropriate for hand jetting, punches, or drills. The soil may not even be appropriate for well pointing at all, and another method such as hydraulic submersible pump systems may be the best choice. Cone of influence. When this information does not give clear guidance, we use computer software which simulates the dewatering process and can predict how long it will take to achieve dewatering. MobFlow is one software that is often used. In addition, we use in-house tools such as TDH, Total Dynamic Head calculators. Also, we always want to consider, are there any risks to our dewatering plan that emanate from outside of our system? The EPA publishes contaminated sites maps. You may find that an adjacent property is a contaminated site, so your dewatering plan must take the contaminated site into account so you don't wick contaminants from the adjacent site to your site. Another consideration is always, what are we pumping? Typically, we're pumping water, but Holland Pump has been hired to remediate arsenic, lead, gasoline, jet fuel, and other substances. Whatever medium is pumped through the pump system may affect the pump lobes, which are made of MBR rubber, and pump seals. So these questions need to be addressed at the outset with a plan in place concerning any damages.
Sock in high permeable soil is an excellent option for dewatering. After hooking up to sock, vacuum relief should be backed out on initial startup. After starting pump, vacuum relief should be set for 1 inch of mercury for every foot from intake inlet of pump to the depth of your sock is in the ground. If your sock is in the ground 18 foot and your intake on the pump is 2 feet from ground level, you would need to set the vacuum for 20 inches of mercury. Most sock is rated at 24 inches of mercury, but do not run over 24 inches or sock could collapse. Retape all your fittings on intake side of pump. This is almost always needed on initial startup. After doing this, you should check to see if further adjustment of vacuum relief is needed. On startup, the discharge water will be dirty for a short while depending on the soil. It could take a few minutes up to a few hours to clean up. If discharge water starts getting dirty after it has been pumping clean, or if the pump stops pumping water, take the sock flange off the pump and inspect the strainer basket. It is possible to have a sock line come apart at the header to sock fitting or any connection below the ground, or even become compromised by excavation. If this happens, clean the intake screen, flush the water tank, pull inspection cover, and check lobes for damage. If all looks good, reprime the water tank and repair sock or abandon it if it cannot be repaired. The tape connection should be checked a couple of times a day. A good indication of an air leak would be a fluctuation of the vacuum gauge, needle bouncing, or loss of total vacuum. It would be a good indication also if you check the end of the discharge and you are getting nothing but air. As a rule of thumb, try not to throw the end of your discharge into a pond. If you can't see the water coming out, you may be fooled by air blowing out of a submerged discharge hose.
Problem 1. Pump has a high vacuum and receiving very little water. Likely reason, water is not flowing to the points, clogged risers, or points.
You and your customer thought you knew the ground conditions well, but your points are clogged or water is not flowing to them. The probable solution is to reinstall them with sand so sand forms a filter through which water enters the point without clogging the point. Solution 2. If the pump continues to have high vacuum and is getting very little water, it is possible that the permeability of the soil is poor and you may need to bend your pump down to achieve a satisfactory cone of influence.
Problem 2. Low vacuum reading. Likely reason, faulty connections, cracked or broken header or Wellpoint material, shorter points in the ground, or points not installed at the same level.
On large excavations, the cone of influence may indicate that dewatering is not easily achieved in the center of the excavation, and dewatering may then be achieved by installing a secondary Wellpoint system or another system, such as a whistle well, prime-assisted suction lift pump, or hydraulically driven submersible system to assist the perimeter Wellpoint system for a large excavation. At Holland Pump, we are working hard as individuals and as a team to be better. We're committed to solve your fluid handling problems and to play it straight by always conducting business with personal integrity and high ethics. We exist to help you finish faster. When you win, we win. We win together. Thank you for attending this webinar today. Jamie and Terry are now available and standing by to answer any questions you may have. Thank you.